Hello, everybody. Are you good? Okay. So give me a thumbs up if you can hear me and you're all good to go. Yes, that means you're locked in. We're interactive now. You're here, you can't leave. You're done, you're here. I'm so excited. We're all so excited to be able to present this to you. Accelerating Innovation Securely, featuring JPMorgan Chase. So I'm Alexis Robinson. I'm in internal security. Leave it to my partners in crime to be able to introduce themselves.
Hi, I'm Scott Cruikshanks. I've been part of the JPMorgan cybersecurity team for the last 10 years.
Okay, Greg Apple, tech lead for cloud operations. I've been at Amazon about 8.5 years.
Yes. So we are so excited to really show you what we're going to be talking about today. We're going to first talk about how AWS embeds security into what we build and why we do that, how we do that, and some of the amazing tenets that we live by day to day to do that for us, which inherently downstream impacts you guys. Secondly, we're going to talk about how AWS services can enable secure innovation, right? Like how it can enable you guys to be able to do what you need to do and which services really drive that for you. Then JPMorgan Chase themselves are going to share their story of how they use AWS services to secure innovation. Hopefully at the end of this, you'll understand that security is not necessarily a blocker for innovation, and they shouldn't be designed to be that way. It should really accelerate how you think of innovation. All right, so what does innovation have anything to do with marbles? Besides playing with this with my son pretty much on a regular basis, what does this have to do with innovation and your delivery roadmap? It's rhetorical, you don't have to answer, I promise you. So first, speed to innovation is like a marble run. A marble run is a series of tracks that end up going to the end, right? The marble is a product and your customer is the end of that run, either a bucket or some sort of holding area where those marbles are going to, right? So at the end of the day, we're all trying to get our marbles to the end of that run in the hands of a customer or end user. So think of it like this. This is a marble run in action. So every marble, think of it that the blue one is probably going to be product A, EC2. The red one is, say it's like S3. Yellow is like a deliverable, a solution, another thing to give to the client, right? All of it's going down a track towards a destination, and that is the actual customer. Now, what goes wrong with this is sometimes marbles go completely off course. And there's a lot of reasons for that to happen, but at the end of the day, marbles that are running off the track can either not meet their target expectations. Customers are expecting those marbles to get straight to them, and when they're going all over the place, like in this video here, it's not good. Or if there's no guardrails at all, or there's no security controls at all, there's no blockers at all, and there's cracks now in that marble, there's some flaws. Or they just miss their intended targets altogether, and it's just going amok. So no customer, no end user is getting it, no one's able to play with the marbles again. It's a done deal, game over. So the first thought that people have is, oh, I gotta have some security controls in place here. But you don't want to design your security so that it becomes end up being a blocker. And that, for a lot of security practitioners, happens very frequently. So you don't want it to look like this, where you're stopping innovation completely. The marble's going down the track, and it's not even getting out. It's considered like, it's kind of like compliance at some times, so people think of it compliance that way, when you're not preparing for it, and all of a sudden the customer at the end is like, wait, it didn't have SOC, it doesn't have ISO, it doesn't have FedRAMP. Well, you're stopped before you even out the gate. It stops your builders before they can even start, and it stops innovation from going live. You don't want it to be like that. Another example is a backup, right? Where, yeah, you have a security control here, and it's monitoring and it's reviewing the product to make sure that it's right and sufficient, but it's really too slow. It could be performative and burdensome, right? And that means your products are missing some critical delivery windows. End users are waiting and you're still not meeting their expectations, even though the train is moving, right? Another example, and this is my favorite, is like security for show. Not my favorite because I like it, but my favorite example. Just want to make sure it's clear. So this is where you have lack of really proper quality checks. You're not meeting customers' expectations too, because you have some things in place, but it's not really stopping anything, it's not really checking for anything, and it's still going, and you still have flaws. At the end of the day, if you get a product out the door, and you're not meeting customers' expectations for the quality and the security, you lose the end user's trust. It's like, yes, you got it to me, and you may have gotten it to me early. Like, great, wonderful. It still didn't meet my requirements and my expectations, and that's when you have to roll things back, and no one likes that. No one likes that, right? So how can we put security controls in place without significantly slowing down innovation? How do we get it to look like this? Where things are going, things are humming. You have all these blockers, you have all of these situations that are coming here to check and balance what's going on with the flow, to make sure that these marbles meet the quality standards that we all have and our customers expect, but still moving down the train, moving down the timeline and the delivery pathway. This is what you want to get to, right? So let's take an example from us, from AWS, how we embed security into what we build. I'll start off with a quote here. I always take a quote. For those that know me and have followed anything that I do, I always kind of steal from our leaders. Our new director for security assurance, Sarah Duffer, she lines it like this. It always starts with the customer. You always have to think of the customer first. Not about just security, it's the customer first. And understand the customer journey and what they're doing in order to do security right is first and foremost a priority for you to be able to have security in your innovation delivery path. So, what is the customer journey for us? So yes, there are external customers, which is AWS users, that's very important. And a lot of things that we do internally downstream affect you, right? But our internal customers are engineering teams, our service teams. They're building the amazing innovative products that you guys see at Inforce here, at reInvent, different times. That's what they're doing. We're doing this for them. We have a kind of a mechanism called tenets, right? And if anyone's heard of tenets, it's like the living and guiding principles that our organizations live by. So I wasn't able to get all the tenets here, but I was able to summarize all the tenets that we do from a security mechanism perspective into 5 Ps, just to make it a little, little fun and snazzy, right? First one is purposeful. Next is a partnership. Painless, provable, and progressive. These 5 Ps is how we live when we create security controls. We're gonna go through each one. The first is purposeful. So what does that mean? It means that you're intentional about your security control. You know why you're doing it. You're not copying and pasting a NIST control or compliance requirement. You're not taking a policy from your organization, copy, pasting that, and throwing it at an engineer saying you must do it. It needs to be based on a real risk or a potential threat that's explainable to a non-security or non-compliance person. It's threading that needle from a regulatory, compliance, or security risk and requirement down to someone that has no clue what the heck security actually is. And not that they don't know what security is, but don't know it the way that we know it, security practitioners. An example is vulnerability scanning. We all know what that is. But it's easy to explain the need to do a scan to find vulnerabilities before a product is launched. It's easy to explain that because no engineer wants their product in the news because a customer used it and it was exploited that was preventable, right? No one wants that. But you have to talk like that in those terms. That's what's important. The next is partnership. It's not that you take a control or take a compliance requirement and give it over to another person that's going to have to actually deal with it and endure it. You don't want them to endure it. You want them to understand that it's there. But you want to make it an actual appropriate partnership between you as a security expert and the engineering teams that have to execute or walk through your security controls. That's important. In other words, ask them outright, what would be the best way to implement this security control? Bring them along for the ride. A lot of engineers actually appreciate that. Not just, okay, you must do it. It's like, hey, I'm struggling with something here. I'm trying to figure this out. The regulator or the compliance authorities, they want this. And I feel like there's a really unique way of doing this. And usually when you think about it that way, like, and you talk to another partner within your team that way, then it brings them along for the journey and they're gonna want to help you. And they might have better ideas of how to implement it, better than you could even think about, because they know their environment and they know we'll be able to give them the best results. Example of that for us is security code design reviews. So it's performed in the early stages. It's a consultation before a developer finalizes, or sometimes not even before they even finalize, before they even complete the design of their product. They work with security engineers and guardians to get guidance early, so there are no red flags later in the launch process. Not saying that there will never be red flags, obviously, because you have to develop, but they'll at least be able to workshop some of those scenarios ahead of time. And that's what's a true partnership. The next is painless. I see you going here. Painless or painful? Painless or painful? What do you want to do? Obviously, you want to make sure that your security control is painless. The best security control is something that an engineer barely even feels. So painless is the name of the game, and the easiest way to sell or introduce a new security control that has some risk that you're trying to prevent is to sell how easy it could be. Now, these are building blocks on each other. Obviously, you need your purpose. Obviously, you'll need your partnership to be able to think about what could be painless. But this is a goal you have to have. So one of our distinguished engineers, Eric Brandwine here, lives by a tenet derived from this. So we have many internal controls that engineers might think is to make their lives easier, but they don't actually know that it's designed for a security purpose. Like, they're so excited to use this thing, they don't even know that it has an underlying security reason for why we even created it. And that's called good marketing. So think about that when you're introducing a security control in your organization. The next is provable. So remember that previous video of that wheel and the marbles getting backed up, right? Another reason for why there's a backup in your innovation pathway, in your launch process, is because your security control isn't provable. What I mean by provable is easy for someone to say, yes, I am compliant with this thing. So example is documentation, right? Some engineers, they do not honestly know how to document for a security or compliance requirement. They don't know how to do that. So you make it easier for them to understand what they have to do, and we're not going in circles, and it's easy. Oh, as long as you've done this configuration setting, the configuration setting is set to this. They don't need to know all the security controls. They don't need to know all the compliance requirements. They don't need to know all the laws and regulations. They need to know, what do I have to do to prove I'm good to move on to the next stage? Get it down to that language, and get it down to with screenshots, examples. That actually helps. So think about making your security control easily provable. And as it's a building block, if you're thinking about purpose, if you're thinking about the partnership, if you're thinking about making it painless, you can easily get to that. An example is our launch review process, right? It's a series of clear yes or no tests before prod launches, where there are documented records of how previous engineers have responded, and they tie out to guidance throughout development. So no one's surprised about how to go through that process and how to implement that control, right? No surprises. It's important. I didn't make a 10 for that, I didn't make a P for that, but that's something that's definitely in here. And the next is progressive, right? Last but not least, progressive, which means iterative. Security controls can be made for a specific purpose, in partnership, provable and painless for a period of time. What's good yesterday may not be good for today. So you don't want to rest on the laurels of what you've done and implemented 2 or 3 years ago. You got to keep looking back at that control and see if it actually still works and operates the way that you want it to operate. You can do that via a variety of ways to inspect your control. You can review the average time it takes for an engineer to start and complete the control. You can review any root causes for errors of the control, and you can determine the best path for starting and stopping a control at large, right? But if you're not thinking about that in the beginning, for instance, if you're not capturing metrics of how long it takes for an engineer to go through that, then it's going to be very hard for you to improve. You have to rely on anecdotes and things from other people to tell you, oh, it's not gonna work, or oh, this is hard for people to go through. And you're not gonna really understand that. But if you are really a security practitioner, You want to make sure that not only is your security control working, but that it continues to work. There might be new ideas to implement it even better now than before. So, this is an example of embedding security as we build. AWS goes through various iterations of all of these security controls before a product actually goes out. We're not going to go through each one, but just giving you an idea. We talked through this over the course of the 5 Ps, but this is something that we go through in general. And this is very like other organizations as well. So it's not just unique to us. And what does that culminate in? Us being one of the most certified in compliance cloud providers in the world. We go through over 300 audits a year attesting to our process. It's ISO, SOC, NIST, like FISMA, IRAP, ITAR, C5, all of that is to attest to the process that we're doing with security controls and our improvement of those. So now, we're gonna go right into our amazing colleague here, Greg. We're gonna go into how AWS services can actually enable you for secure innovation.
All right. Thank you, Alexis.
Oh.
Can everyone hear me? Just nothing. Perfect. Alexis, thanks for that great overview. Let's talk about the services that you can actually use as a customer to secure your own innovation. So I'm going to cover Control Tower. We'll talk about organizations, CloudFormation, Config, CloudTrail, IAM, SCPs. These are some of the services that customers can use in AWS to secure their pipeline of innovation. And we can really break this down to 3 critical use cases, and I'll cover these in order, right? So the first is planning your landing zone. The second is customizing your accounts, establishing that baseline for those accounts. And then the third is enforcing standards through those controls. So let's talk about the first one, planning your landing zone. In many ways, this is about establishing your foundation on AWS, right? If we think about the marble run metaphor, we want to make sure that the marble run that we're building is on steady ground, is on a solid foundation, right? So you want to build a landing zone within AWS that is well architected, secure, and scalable. So this is the really important first step. And so customers, I talk to a lot of customers, hundreds of customers a year about governance, compliance, operations, and observability. And a lot of customers will ask, well, where do I start? I would say if you're just starting out right now, start with Control Tower. I think it's the easiest way to get started, right? We're going to help automate the creation of accounts, and we'll apply built-in governance to those accounts. We also have a controls library, which I'll talk about and we'll do a demo of. And this helps you enforce your best practices, standards, and any regulatory requirements you have. As you think through and as you use Control Tower or organizations to start building out this line zone, I'd give you a piece of advice. Just keep things simple, right? When you use Control Tower and you configure it for the first time, we're going to create one OU. It's a security organizational unit. You can create an optional sandbox OU for your software development environments. But from there, the rest of it's really up to you, and I'll provide a resource for some guidance on what you should do next. But keep things simple. Your OUs, and this is really a key best practice, is the OU structure within Control Tower should not reflect your business structure. I can't stress this enough. I work with a lot of companies and they think they need to map their business unit structure to their OU. And people are constantly, ourselves included, constantly reorging. When you go through reorg, that's going to introduce a whole world of hurt if you have to then go back and remap and reorganize that OU structure. So do not map your OUs to your business structure. They should reflect your policy structure within the organization. And here's an example of a Control Tower architecture, right? We have a management account, there's a log archive account, an audit account, and then a bunch of provisioned accounts, right? This is pretty standard. I'm not going to go too much into the details, but I do want to point you to the bottom right there, which is a QR code for one of our most popular white papers, which is a white paper on organizing your AWS environment using multiple accounts. So I highly recommend you read this white paper if you haven't seen it before. No need to do everything it says. It's going to give you a lot of guidance. You can go through that and implement what makes sense for you and your business. But cannot stress enough, this is the critical resource that you need as you're thinking about building your landing zone. All right, so let's talk about the second use case, which is about customizing accounts. So we've built our foundation. right? Now that we have our landing zone, we've created some OUs, we've created some accounts, we've read the white paper I just had on the previous screen. So now we need to start to customize these accounts. We need to establish a baseline for those accounts, right? So we need to start building that structure so we can secure our innovation later on. And these are some of the top customization categories you may have, or the ones that we see when we talk to customers, right? So the first is identity. Many folks want to provide access to their AWS accounts through an identity provider. So oftentimes that's one of the very first things they'll set up and customize when they provision that new account. And then other folks often have very specific security tooling they want to put in place, right? We have a very rich partner ecosystem. There's a lot of tools out there. A lot of customers want to get those tools configured when that new account gets baselined. And we can't forget about networking, right? Networking is really one of the first things folks do when they spin up a new account. You need to establish your routing tables, your VPC structure, how you're going to do IP allocation. And then typically after all this, we see a lot of customers think about what other logging can I turn on in these accounts, right? So with Control Tower, we're going to automatically enable CloudTrail management events. There's also data events within CloudTrail as well. VPC full logs, WAF logs, firewall logs, Amazon CloudWatch logs. And then controls, right? Let's not forget about the controls, but we'll talk a bit more about this, especially around like config rules, CloudFormation guard, as well as SCPs. So the next question you may ask is how do I actually customize an account, right? So if you're using Control Tower, we do emit a lifecycle event. You can capture that event in EventBridge, and that event can then be used basically to start a workflow to customize and baseline your account. Now, luckily, most folks don't have to do this. We do have solutions for this. We have both solution-based and service-based options for you. So if you're a Terraform customer, we have something called AFT, or Account Factory for Terraform, and this is a solution-based approach. And then if you prefer CloudFormation, we have a solution-based approach very similar to AFT called CFCT. And then there's a native service capability within Control Tower that lets you manage, basically provision and baseline those accounts directly within the service. You don't need to stand up a solution. I'll do a quick demo of that as well. But trying to figure out like which one do you use? Again, start simple, keep it simple. If you're just starting out, highly recommend you look at and use AFC. Right, it's a service-managed approach to account customization. It uses CloudFormation. It won't allow you to deploy SCPs, and it doesn't support multiple configuration packages. So it's very simple to get started. That's what I would recommend most folks use. And then as you achieve a higher degree of maturity as you go through, and maybe you need to customize these pipelines a bit more, then start looking at CFCT or AFT. These basically are using code pipeline and are code build, that sort of thing under the hood. They will support SCP rollouts, and you can support multiple configuration packages. So if you want to start simple, go with AFC, and then later on you go and use CFCT or AFT if needed. All right, so the third use case, this is about enforcing standards through controls. So the last step to building a Marble run is ensuring we have the proper controls in place, right? We want to make sure that Marble that Alexis talked about makes it all the way from the start to the finish. We want to make sure that it finishes safely, securely, but also efficiently. And this is where controls come into place. So again, I'll go back to Control Tower. Control Tower, to get started, this makes it very easy. I'm not suggesting that Control Tower has all the controls that you need, but we have a pretty comprehensive library of controls. There's 513 controls as of today. This covers 49 services, 15 control objectives, and then 3 different frameworks. And these controls are broken down by 3 different behaviors. So we have our preventative controls, right? So these are controlled or supported by service control policies, and these are always compliant, right? They're going to disallow the action that would lead to a violation. We then have our proactive controls. So these will scan resources before they're provisioned. So as part of your pipeline, as you're provisioning these resources, a proactive control is going to basically block that provisioning from occurring. These, again, are always compliant as well, and for approved resources only. And then our detective controls, these are supported by AWS Config rules and AWS Config conformance packs. right? So our detective controls are going to detect that resources have violated or do not violate your defined security policies, right? And you want a mix of these, right? You don't want just to go with preventative controls, implement preventative and proactive controls, and use detective controls to validate that those other control types are actually working. So let's start with preventative controls. Again, this is a 300 level session, so hopefully most people know what SCPs are. The only thing I would basically add to this slide is it's really important to remember that there's policy inheritance with SCPs, right? So you can define a policy at the organizational root that disallows a particular service, and even as you go further down, basically the hierarchy, if you, within your account or OU, say, hey, you can actually use the service, that will get overridden by what's at the top. So just remember there's a policy inheritance to SCPs. Another thing to remember is SCPs do have limits, right? If you check our documentation, it spells out you can only have a certain number of them per root, per OU, per account. So try as much as possible combine your permissions, your policies within one or two, or don't get too granular basically and try and create a dozen SCPs. That's not going to work. You want to combine this as much as possible into a single SCP. Now let's talk about proactive controls. Again, at the end of this, I'm going to go into a demo. I'll show some of this. But our proactive controls work like this. You take a CloudFormation template, and we leverage something called a CloudFormation hook. This is really the fundamental piece that makes proactive compliance work. So when CloudFormation goes and provisions that resource, a hook is basically invoked immediately before the creation of that resource. And then you use something called CloudFormation Guard, which is basically a policy as code evaluation tool to basically determine should this thing actually get created. If it fails that policy, that resource simply does not get created. It stops it right in the pipeline. If it is approved and it's going to provision a compliant resource, then it basically lets it go ahead. Our last control behavior is detective, right? So we're going to detect resources that violated your defined security policies. And the way this works is AWS Config is a service that continuously monitors resource changes and records them. That then you can set up a rule to evaluate. So if this thing, say an EBS volume is not encrypted, I want that to be non-compliant. So Config is going to continuously look at your resources as they change, as they get created, and it will evaluate this and say, is this compliant or not? And then so when it does go to a non-compliant status, you can trigger a workflow. We call these conformance packs, where you can use like Systems Manager or Lambda to do auto remediation, and then to bring that resource back to a good state. So I know I covered a lot here, but I do want to do a demo that will go through a lot of the things I just talked about. So just bear with me 1 second. All right, so I'm in Control Tower right now in my account. I have a few OUs and I have a few accounts. So I'm just going to go through here. You can see like a testing, a development, a production OU. And I have a bunch of accounts here. So I have some testing accounts, a sandbox account is actually getting provision right now. And then I have some other accounts there. So just bear with me 1 second. And so with like a Control Tower, you can basically look at your whole org structure. You can look at all the OUs and all the accounts under there. I'm just navigating basically through my organizational tree within Control Tower. And so what we're going to do, I'm going to actually show in this demo account factory. So I talked about account customization and how you can basically set up a baseline for your account. So you can say, if when this account gets created, I need a baseline, I need to have all these things installed and configured. So what I'm going through right now is an account factory. I'm creating a brand new account within Control Tower. I'm putting in all the details I need to put in, like my name, contact details, the login, and I'm going to select my OU here. So I'll just pause this for a second. So I'm creating a brand new sandbox account. I'm now going to put that sandbox account inside my sandbox OU. And what you'll see here at the bottom is this thing called account factory customization. This is AFC. So I go into AFC, I put in an account ID. This account ID is where I store my catalog of customizations that I talked about earlier. So in this particular account, I have a series of service catalog products, and those products baseline my accounts. So I validate the account. I then say I want to apply, and you'll see right there, I want to apply my sandbox baseline. So this is a customized package that will baseline my account for a sandbox type of an account. We go ahead, validate that, select the version, and then choose the deployment region here. And then we go ahead, and then this will then effectively go get created. We go ahead and create that account. So I'm going to pause here. So that is basically account customization. The next thing I want to talk about is basically controls, right? So we talked about how you start with Control Tower, you customize your accounts, and then we talked about controls. So we're going to look at a control that's related to EBS volumes not being encrypted. So let's take a look. I've just searched for this particular control. And what you'll basically see here is this is a detective control, right? So we're going to apply this in our sandbox account. I'm just highlighting here, this is AWS Config rule. And so this is going to look for volumes that are attached but not encrypted. So whenever we find an EBS volume that's attached to an instance that is not encrypted, that's a bad thing. That falls out of compliance for me. So we go down here. You can see basically the OUs that we've enabled this control on. So in this case, sandbox and the individual accounts. My sandbox account now has this control applied basically to it. And we can see how this control is made up. We can look at the artifacts. So in this case, it's a config rule, and you can see the definition of that config rule basically right on the screen here. So you can actually look at the underlying code behind these controls. So go through here. And what you would then do if you want to enable this on other OUs, maybe we want to apply this to like the production or the development OU, we just click enable, select our OUs, enable the controls, and that's it, basically, to enable a new control within Control Tower. So now I'm going to go into the sandbox account, and we're going to try and actually trigger this. We're going to make something not compliant. So I'm going to go into EC2, I'm going to create a new instance, and we're going to make sure the volume is not encrypted because we want that detective control to pick that up. So we'll call it my test server. I think I'll largely accept the defaults here, and I'll point out as we scroll down here that this volume, you'll see the volume is not encrypted. So this volume, the EBS volume that's attached to this instance is not encrypted. We'll go ahead and then launch this instance in a second. And then we're going to go to config and actually look at make sure the detective rule is actually picking this up. So the instance gets created. Again, I've pre-recorded this, so there's a cooking show magic here, right? This takes a few minutes. This will be done in a few seconds. So here's our EC2 instance. We have our EBS volume. We'll go over to config in a second and see that this, it will pick up that this is not compliant because we have not encrypted that particular volume. Okay, instance is fully provisioned. Now we head over to config. And as we go to config, what you'll see is you'll see one of our rules here, right? So this is that Control Tower rule I just enabled. That's the detective control in Control Tower that says your EBS volumes must be encrypted when they're attached. So right now, it hasn't found anything. Typically, you wait a few minutes for config to pick this up. Again, I've shown that by pre-recording this. We'll go ahead and do a reevaluate, do a refresh, and what you'll see here over on the right, you'll see it's kind of red there, so it's actually found a violation now. Right, that EC2 instance actually had 2 volumes, and what we can see here is those are the 2 volumes. They both are not encrypted, so they're non-compliant, because the detective control is looking for volumes that are encrypted, and if they're not, it's a non-compliant thing. And you get more information about that particular resource as well. You click into each of the individual resources that are causing that compliance issue. So let's look at another control. This time we're going to look at this from a preventative control perspective, right? Very similar control. We want to make sure the EBS volumes are configured to be encrypted when they're attached. But this is a preventative control. This is not a detective control. So maybe this is not something, in your sandbox environment, developers might have a lot of freedom. So maybe use a detective control in your sandbox environment. And when you go to prod, this is where you would want to put preventative control into place. So we go ahead and look at this control. Again, you'll see that this says preventative and not detective. So it's a SCP. SCP is how we're accomplishing this. And very similar to last time, you can go to that control. In the controls library, you can see which OUs we've enabled this control for, which accounts, and then the artifact. So in this case, the artifact is going to be an SCP. I'll pause there just so you can take a look. So this is basically just an SCP statement that's saying, again, deny any volumes that are not encrypted when you attach them. So we'll go ahead and enable this preventive control. We're going to enable this in production. Go ahead and enable that. And then what I'm going to do is I'm going to create a new volume and trying it in this production account and trying to attach it, and it should fail right away. So I'm actually going into this OU here just to show you. So it's applied this new policy. If we click that top policy, the policy at the top, and scroll down, you will see that that control tower has taken that control, that preventative control, and it's applied the policy in organizations at the proper OU. Now let's go to EC2 and go create new volume. So we're going to go into the production account, going to go into EC2, and we're going to create a new volume and try and attach it and make sure it's not encrypted. So I'll go into EC2 here, go to our instances. You see we have our test server here from before, and now I'm creating a new volume. There's the encrypt button. I'm going to make sure I don't check that, and we're going to go ahead and create the volume. So the volume creation will happen because the policy is not about creating unencrypted volumes, it's about attaching unencrypted volumes to an instance. So now we have this volume. I'm going to take that 100 gigabyte volume we just created, and we're going to try and attach this to the instance now. Remember, we're in our production account. We have the SCP enabled, the preventative control. We click attach, and we automatically get an error. This is expected. So we've prevented people from doing something in our production account through a preventative control. Right. If I had more time, I could show how you can use detective controls to make sure that your preventative controls are working. But I want to make sure we give time to Scott from JPMC to share their story on how they're securing innovation. Go ahead, Scott.
Thanks, Greg. Oop, take my headset off. Thank you all again. First of all, I just want to say thank you very much for giving me the opportunity to share some of the learnings we've had here at JPMorgan on our journey to enabling services securely. Just for a bit of background, for those of you who may not know, JPMorgan is actually the world's most systemically important bank. And as a result, we take building resilient and secure apps as like fundamentals for us. It is exactly what we do, and that's what our customers expect. As part of our cloud journey, we started about 8 years ago, and I was actually fortunate enough to actually be aligned to the cybersecurity team back then, and we've done a slow and steady increase in the number of accounts, the numbers of services we've used over those years. And what we found during that journey is it is all around sort of this coming up with a standardized process, but I will dive into that in the next slides. But first of all, the other thing I want to do, almost from a risk perspective though, to the firm, is just point out that security risks, whilst in my eyes are super important, there is also the business risk here of if we don't get the latest technologies into the hands of our business developers, then that's actually more of a systemic risk to the actual firm as a whole. And I'm sure everyone in the audience can think of organizations that haven't used the latest technologies and have find out that years down the line, they're behind, can't come out, and suddenly they're out of business. So whilst everything in my mind is all about everything needs to be taken, security is like the number one priority, the easy option would just be to say, no, you can't do it. Back to the blocker that Alexis pointed out in one of the early slides in the marble run. That's really just not an option for your business. You have to get these latest technologies into the hands of your developers because other competitors will be doing it. So that I just wanted to level set there is like the option of saying no, maybe the most secure way of doing it, but it's just not an option, and the risk on the business side are way higher. So kind of in terms of how we've done it, what we've learned over the years in terms of enabling these services, as I said, we started quite slowly, methodically, and we've kind of just started cranking that notch, but we've learned a lot during the way. So now we've got thousands of accounts, so everything we do is done in a thoughtful way, just because of the scale. Anything we do centrally has a mass impact. So what we found is, whilst we're not having a central team review every service and stuff like that, we've developed a centralized process and tooling mechanism, which we then can federate out throughout the business in a consistent way that would allow people to use services when they want them. That time to market comes down, but the security does not drop because we've got checks and balances throughout that process to make sure that everything that reaches the product that gets delivered to our customers in our centers, like the line of business applications who are there building their banking applications, driving value to our customers. just the efficiency of having this standardized process, and I'll go into the actual process into more detail, is key. And again, it's all about just using these efficiencies. If I can flip to the next slide, is about making sure that throughout the firm, we don't have 10 different marble runs. We want one process, one marble run, but you want our engineers throughout the business, both in other product lines. I myself are aligned to the Cloud Foundational Services product line. We enable quite a lot of services ourselves, but there is other services. You've got databases, you've got runtime. They all have their own individual marbles. We don't want them all building their own marble run for their marbles. So we've just got this central marble run where hopefully everyone can seamlessly drop their marbles in the top, roll down, and come out as a nice secure product we can then offer out to our line of business organization. So again, not trying to centralize the reviews, just centralizing the process everything goes through. Of course, there is some real challenges to enabling new services. The big one and the big thing about enabling a new service is you want to make sure that there's no misconfigurations. I think it's quite a well-known and well-publicized fact that the misconfiguration of cloud services is the #1 causes of public cloud breaches. So we're very conscious of that. So wherever possible, we are trying to use this secure enablement process and the toolings we've got built in it to ensure that they're minimized, ideally completely made disappeared. So the other thing, being a large financial institution, we're heavily regulated, and rightly so, and the same as some other industries. Though, as a result of the regulatory oversight, everything we do, we need to evidence. We need to be able to prove it, and we want to be able to do that in as streamlined a way as possible. Again, we want our engineers building business apps. We don't want to be using our engineers' time going out and responding to regulatory RFIs. So anything we can do within that process to collect the data, make it more consumable to internal audits, external audits, is better. And as I say, for us, regulated by way over 200 different regulators around the world, this is a very real thing. We need that data, and we need to be able to find a slick way of getting it out there. And likewise, actually, the expectation on us is that governance and control is baked in. It's table stakes for us. Like, we have to do it. It's not an optional. So how do we do it? What is the thing we go through day to day? The very first thing, and this may seem fairly simple, but it's actually establishing a controls catalog. And it makes sure that controls catalog takes into account the risks, sometimes new risks, cloud's not that new, but the risks that are there in the public cloud. And it's using that as your framework. We make sure your regulations are part of that, within that controls catalog, use industry standards, but you kind of need that high bar. These are the things we need to do. So we've got it as a firm, and I'm sure a lot of other companies do as well. The next thing, when we're trying to look to turn on that very new service for the first time, is we need to go into that controls catalog and see, does this control actually apply to the service? So an example I can think of the top of my head is kind of data encryption at rest, very standard requirement, but it's not needed for a load balancer. So you're kind of doing this up front, and we've got process and some tooling around this to bake it in almost a float step. But ideally what you're trying to do here, and I think Greg and Alexis mentioned earlier, you're trying to start building out the non-functional requirements that your engineers are going to use to build this secure service. Like, without telling them up front in clear and concise ways what they're actually going to need to do, they'll find out too late. And you don't want to be doing that. This should be done right up front. Before anyone's even written any code, you should be working out which controls they actually need to build. So the next stage for us is then to look at those controls that are applicable and go, what is the actual configuration setting? By that, I kind of mean, and Greg showed a couple, and I've got some on a later slide, what is the actual configuration setting that we need to set via the AWS APIs to meet that control? Is it turning something on? Is it dialing something up to 10? Whatever it may be, trying to define that and tying it back to that control that you've got in your controls catalog is key. And trying to start tying together this lineage, trying to track this tracing of this thing meets this control is key. Just a bit of insight for us, we've learned not everything can be done cleanly via the API, so sometimes we have to do build some controls a bit more custom ways, sometimes use custom lambdas. But similar thing, you just tie it to the control objective. So it's all trying to trace through that lineage as we go. So once you've actually done that and you've identified the settings, the control it maps to, is then at this point, we should be going to the engineers. Here, we've given you your non-functional requirements. Please go build it. We as a firm leverage quite a lot of infrastructure as code, so you build it into your templates. Terraform, CloudFormation, whatever you may be using. So that's what we do. As I mentioned, you can put stuff into the SCPs, you can use identity, like IAM roles, you can even, as I mentioned, use custom lambdas. But really start thinking, we need these preventative controls in place. So we start preventative first. By doing the preventative controls, ideally that means that whenever anyone takes that template, and we have a marketplace where application teams can only really use stuff out of our marketplace, so they can only provision stuff that should, in theory, come out secure. They should be in compliance with those control objectives. During time and stuff, with maybe you have an instance, maybe SRE have to break glass, go in and make some manual tweaking. Some drift could be introduced in. So we also make sure that that exact same configuration setting or control has a detective control in place as well. So similar to Greg showed in the demo there. So like you're starting to trace it. So you've got to identify the config setting, put it in a preventative control, put it in a detective control. The other thing we do for our most critical controls, think public S3 bucket, something like that, is have an auto remediation as well. Just in case somehow something somewhere completely breaks and the bucket gets public, as soon as it's noticed, flip it back immediately. So again, this is stuff we've built, and again, just still tracking through the lineage, and I'll come on to why that's important in a minute. The next thing we've done, and this is a more recent development for us, so kind of, I should say up until this point, we've been running this process for like 3-4 years, and we've got a bit of muscle memory around it. More recently, we've started to build a few environments and some tooling around it, which allows us to write some tests. So we actually try and provision, similar to actually Greg did in the demo there, test that these preventative controls are working. So we're trying to stand up some non-compliant resources. This allows us to get that evidence that our controls are working. And again, we're doing this new service hasn't gone live yet. We're doing this before it goes live. We then write some tests for the actual detective controls. So this time we've got a special environment where we're actually deliberately misconfiguring some services, and we're testing that our detection rules and our remediation rules are firing. So it's taken us some time to gain the comfort and the restrictions around that account. But doing that, again, just proving everything works. And this is, again, tied back to the big audit regulatory burden. This helps us. This not only gives us confidence internally within sort of the engineering teams that everything works, and it also helps us then just to ship this evidence on to our auditors. Only at this point where we've identified the controls, config settings, the detective rules, the preventative rules, the remediative rules, and then we've tested it all, are we then going to push the controls, so the new service into production? But even when it's there in production, these services are always there, remediating any drift. The other thing we do is potentially for some of the less critical controls, if we discover any drift, the thing we spent quite a bit of time doing is then plumbing that into our broader GRC ecosystem within the firm, and we would notify the application teams. You've got this, we've noticed this misconfigured bucket or this EC2 that's running out of compliance, go fix it. Here's your SLA. So we've kind of done that by leveraging the firm's pre-existing GRC ecosystem. So we've plumbed it all in to make sure everything maintains this ever compliant state. And I kind of already touched upon this final point. All the way through this step is tying it together, trying to trace this through together, and collecting evidence for it. Because we very much do have to prove this. Not just to ourselves, we have to prove it to us quite regularly to all sorts of stakeholders. So the more we collect, the less time we have to manually go run queries and stuff, the more time developers are spending delivering customer value. So kind of just to start summarizing some of these, the key learnings we found is, and we haven't always done this, and this has been a journey for us. As I said, it's been 8 years of doing this, is shifting those controls as far left in the process. So it is just trying to work with those engineering teams, going actually really a lot of the engineers, I know a few of them are in the audience, they are our security engineers. I know I'm sat in the security engineering organization. The people actually building the controls though quite often sit within some of the other parts of the organization. But for us, it's making sure we give them the clear requirements as early as possible to make sure that there's no surprises. They can go build them in, they can plan it, they can work out what the challenges will be. The other thing is, as I said, not everything is relevant for every service. Covered that one. Sometimes the control is not actually the customer's responsibility either. So you have to identify that, flag it, know about that. The other one is actually even at the infrastructure level, there's some controls that the infrastructure alone can't take account for. I know EC2 has some, so does EKS, where the applications themselves have some of that responsibility. So even internally, you've got to work out that shared responsibility model and then a way of making sure that those applications themselves, before they go live, know that their control is in place. And so we've got similar tooling in place for them, for the applications to do these assessments. So we've passed on that burden. But that's actually a really critical one, because I know an example, because I use it in a minute, is sort of actually for something like EC2, making sure the data is encrypted in transit all the time. You can't always do it. Like EC2 is an example where you can't. The application is the one that's ultimately responsible there. So you can't always do everything at the infrastructure level. And then just coming on here, I just wanted to really emphasize what we actually mean by config setting here. I know I just used the encryption in transit example for EC2. Actually, if you look at it from S3 perspective though, you can define a config setting for it and you can take care of it from an infrastructure level. So kind of what we defined here, most controls catalog, I'm pretty sure all of them would have a requirement that all data in the cloud should be encrypted in transit. What we've done here is identified that within S3, if you have the AWS secure transport flag as not being false, you'll have that control covered from a perspective. And then what you can then look to do here is sort of just as a Terraform statement, a deny statement where it's just a clear, if ever you see secure transport set to false, just deny it, just won't build it. So that's just an example of what we mean. So again, full transparency, not all of these config settings are that simple and that clean. So there is actually a reasonable amount of effort needs to go into defining these config settings. But just as we start to conclude here, just kind of to start summarizing what we've learned from our journey, is that actually those security controls, and by doing stuff early, speed up the process because you're not getting blocked at the last moment. You're not going live and then having a recall. You're not going live having a lot of regulatory burden or internal audit burden because you've done something in an incorrect way. It genuinely does speed it up. And kind of making sure you have those detective controls in place to validate the security controls is also key. And I said, build them before you go live. Test them before you go live. So that when you go live, there's no surprises. And use that evidence that they're working as part of your actual go live process, your release process. And then make sure your process is repeatable. It's like this is a process that works for us. But whatever your organization is, it's just kind of just making it repeatable. Get that muscle memory, do it, refine it, get the engineers involved. And actually, you don't get very much pushback. We had way more pushback before these processes existed. And people had a bit more freedom. So it definitely helps. And then make sure that everything is evidenceable and provable. And that helps just from your own comfort perspective, your own assurance that things are working. But then being able to actually get that out quite easily is key. It will just save hours, if not weeks. And then again, continuously test. I'm sure that's true of all software development, but continuously test everything's working. Somehow, somewhere, I'm sure something will break. So you just want to be testing it and aware of it. And then hopefully, I would say our process, it's getting there. It's getting there. It's not quite to this level of slickness and streamlessness, but hopefully we're not too far off, and we'll strive to get there. And just want to again thank you for the time. Thank you, Alexis, Greg, for allowing me to speak and doing some great oversight overall yourself. Please do come grab us off the side if you've got any questions at all, and I think our LinkedIn details are there as well if you want to ping us or whatever. But thank you very much.